I know in your previous classes that you really haven't had to deal with significant figures, but since there are so many measurements in chemistry, then sig figs are important. And sig figs do have to do with the measurement. They have to do with this measuring device or any measuring device. So when you have a measuring device, you can read between the lines. And do you see here, this is the meniscus right here. That is the bottom of the curve. That is that curve that you see in graduated cylinders. And do you see how it's in between the lines here? Okay, so significant figures are really those figures you know for sure, and then the one you estimated. And even if we think that that is right on the line, we are actually estimating that it is right on the line. It could be a hair above, a hair below. So we are estimating that. So, it's the numbers you know, and then you estimate the last one. And those are your significant figures. That's the point to significant figures. So this graduated cylinder goes from 10 to 15. So this is 5 milliliters here. But if you look, there's 10 little divisions in between. So this one here is 2.5, so it'd be 12.5. And then this one, so this would be 12.5, that'd be 13, 13.5, that would be 14. So we know it's somewhere between 13.5 and 14. And we're going to estimate this, and this curve looks a little bit closer to the 13.5. So I would probably say that this is 13.7 milliliters. Now this is my estimated value. I estimated that. I know these two. I know it's 13. I know it's 13 for sure, because here's 12 and a half. There's 13. There's 14. So we know it's somewhere between 13 and 14. But so we're estimating that last digit. And so this one has 1, 2, 3 significant figures. Now, a lot of times when we're doing problems, our measurements are given to us. So we need to be able to look at the numbers given to us and to tell, okay, how many sig figs does this have? Because that's as accurately as I can report the answer. A lot of times how many decimal places do you want me to give the answer to, Miss Mac? And so that's where this is going to answer that question. Okay, so easiest is if you have a number and a zero, that's a zero, and a number, okay? This one counts. So that's the easiest one. And then if you have a decimal number and then numbers, these zeros do not count. And they do not count because they are placeholders. They're placeholders. So they are the ones that give this value. So this would be the tenths place, hundredths place, thousandths place. So this is in the 10,000ths place. And it's just, these zeros here are just telling you that this is in the 10,000ths place. So they don't count as significant figures. They're not numbers. All numbers count. So like when we did the 13.7, those are numbers. All numbers count. But zeros are the kind of like, well, does this count or does it not count? Now the confusing part are the trailing zeros, the zeros at the end. So we have like number 000. Okay, and those sometimes count. So these always count, these never count, and these sometimes count. So these are the ones that are confusing. And they count when they're in a number with a decimal point. So here, just like, where's my laser pointer? Is that a laser pointer? Yes. Okay, so just like here, these numbers here were place value. These numbers here are place value. That tells you that this is the thousandths place. So this is, I knew these two, or I knew this number, I estimated this number, but this is in the thousandths place. So I estimated that this was like 32,000, and the 2 in 32,000 was estimated. These zeros here are just placeholders. But if there's no decimal point, they don't count because they're placeholders. If there is a decimal place, so if I have blop, blop, 0.000, now I'm saying I've estimated to this. I have some measuring device that goes out to the thousandths place. This could be a milligram balance. And you'll see on a milligram balance that when you weigh something, a lot of times this number will fluctuate a little bit. It'll go up and down a little bit and be like, is it going to be on the 0 or not be on the 0? So you're estimating this one. So this number here would have 5 sig figs. And these count because there's a decimal point. If there's a decimal point, then the trailing zeros count. So this one here would only have 2 sig figs. This one's 2 sig figs because only those numbers count. This one is 5 sig figs because all of those numbers count. That is your estimated one. This is your estimated value. So it gets confusing once you're doing the math with it. So that's just counting the significant figures in the measurements that were given. And you noticed when I was doing your homework, I told you how many sig figs, and hopefully that helped you figure out this. And if it didn't, well, that's what this is for. When we are adding and subtracting, okay, adding and subtracting is about place value. So if I have like a whole pool of water and I added a little cup to it, okay, so I'm estimating that this is like 1,300 liters and this is maybe 1 liter. Okay, I've estimated that this is 1,300 liters. So that 3 in itself is estimated. This 1 liter is, I said, it's about a liter. It's somewhere, somewhere about a liter. I just filled up a cup. It's about a liter. If I pour this in and I'm adding to it, I'm not significantly changing this 1,300 because I'm making it 1,301, right? But this is the 3 here, this is my estimated value. So I can only, this is still approximately 1,300 liters. I can't say more accurately than that. I can't be more accurate than that. That's as accurate as I can be with that addition. Okay, if I am measuring something by subtraction and I have this container and the container is 13.56 grams, I made it up. And then I put some little substance in it, and when I did that, that made the value be 13.88 grams. Okay, so if I subtract those two values, 13.88 and 13.56, I get 0.32 grams. Okay, so this is what's going to govern the rest of my math. This has 2 sig figs, and I can only give this as accurately out to the hundredths place. And the mass of my substance here, let's circle it in a different color. The mass of my substance is only given to two significant figures. And so this is what I have to use in the rest of my math for this. Now, when I'm working with scientific notation, those are basically different values. So if I have 1.32 times 10 to the 5th, and I have 4.65 times 10 to the 4th, okay? So that's 132, move the decimal point, 1, 2, with 3 more zeros. And this is 465 with 2 zeros. Okay, so when I add these together, okay, I'm going to measure to my least accurate measurement. Okay, so this one is estimated to in the thousands place. This one's estimated in the hundreds place. So I have to round to this point. So this is going to be 179,000. Now, a lot of times you do not want to, I mean, if this is like bigger than 5 and 4 or 10 to the minus 12, you don't want to like write this out. So how do you change them so that they have the same exponent? You need to make them the same exponent. So we'll show you how to do that. So making them the same exponent, we have 1.32 times 10 to the 5th and 4.65 times 10 to the 4th. Okay, so if you're going to make the exponent, let's say we take the 10 to the 4th and we're going to make it 10 to the 5th. We're going to make the 10 to the 5th. So if you're going to make the exponent bigger, you make this number smaller. So they kind of go the opposite. So this is 0.465 times 10 to the 5th. And then all you have to do is add these two parts, and then you're going to end up with the same thing. So if you make the exponent bigger, you make the number in front smaller. And then you can do the regular adding, and you'll add this, and you'll get the same number. You'll get 1.79 times 10 to the 5th. All right, adding and subtracting is the hard one. Multiplying and dividing is easy. So when you multiply and divide, you just use the least number of sig figs. So you count the sig figs in this number, count the sig figs. If this is 3 sig figs and this is 2 sig figs, and you get your answer, you can go blah, 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 blah. It can be 50,426.75. I made it up, okay? I'm going to round this off to 2 sig figs, the least number of sig figs. So this is going to round off to 2 sig figs. So this is going to become 5,400 of whatever the unit is. 5,400 milliliters, 5,400 liters, grams, whatever it is. Okay, so least number of sig figs. I know that color's not very good, but questions? Good. If you have questions, send them in an email to me and we will clarify. Thank you. Bye-bye.